I'm Andrea Sampson, the CEO of Talk Boutique, your host and moderator of today's sense-making conversations. Thank you so much for joining us. I missed you guys last week. We still had a great sense-making conversation with John Robinson Jr., our Director of Relationship Development, and Dwayne Matthews, an expert in the educational system. If you weren't able to attend, I suggest you check it out later on our YouTube channel. It was a fantastic conversation on systemic racism in our educational system. I know I learned a lot. Now, I've had to take a really, really hard look at my own complicity in this important conversation on racism, and I encourage you to do the same. John's going to continue with his courageous conversations, which will take place right here every Wednesday. John's going to welcome a guest weekly to help us to understand our own unconscious bias and how we can make the changes that will begin to address the issue of societal racism. Shifting to this week, how are you all doing? Give me some love. I would love to see a thumbs up in the chat bar. To see below the chat bubble, just give me a thumbs up and let me know that you're here. Just give a minute for everyone to come in. I can see you streaming in. Come on, anyone? Give me a thumbs up. Let me know you're here. I know it takes a moment for it to show up in my chat bar, so we'll just take a moment. Great. Okay, I can see Allison is here. Great. Thanks, Allison. Marcelina, Sandra, thank you so much. So good to see you all. Okay, we're finally beginning to get a little bit of freedom from the pandemic lockdown. And if you're like me, we're just beginning to venture outside, and I know we're all keeping our distance, but we're relearning how to interact with family and friends. It's quite a challenge in this time. And the COVID-19 pandemic has had a tremendous impact on our world, with over 7 million people affected and 400,000 deaths. The virus is continuing to impact many. And while these numbers are staggering, the recovery rate is continuing to climb. And that's good news, right? Well, our guest today, Dr. Drew Taylor, is going to help us to understand more about the long-term implications of the COVID-19 virus and how it might continue to be a problem post-recovery. Drew is the co-founder and the chief executive officer of Acorn Biolabs, where they provide non-invasive and affordable stem cell collection and preservation. Drew is a biomedical engineer, a former professional athlete, and an award-winning documentary filmmaker. It's safe to say Drew has had a non-traditional scientific career. He completed his PhD at the University of Toronto in biomedical engineering while enjoying a successful career in professional baseball as a pitcher for both the Toronto Blue Jays and the Philadelphia Phillies. He then went on to become an award-winning documentary filmmaker before jumping into his career in regenerative medicine. Drew continues to be widely published across international medical journals with topics related to tissue engineering and sports medicine. Drew, I am so excited for our conversation today. But before we get started, let me just set up our time together. Drew's going to spend about the next 15 minutes telling us what he's been up to, and then we're going to move into a question and answer format where we want your questions. Just have a look at the bottom of your screen, locate the chat bar. You'll see a Q&A bubble and you'll see a comments bubble. On the comments, just tell us what you're thinking. On the Q&A, that's where you get to enter your questions. All right, Drew, when last we spoke, you were telling me about the work you were doing on the COVID-19 virus. Can you help our listeners understand what's underway?
Absolutely. Thank you so much for that amazing introduction. Very excited to be here. Unfortunately, kind of talk about some pretty serious subject matter. I would think and assume at this point that everybody has been I guess, in touch with somebody that has been directly either diagnosed with COVID, knows somebody that is going through a recovery period right now. But absolutely everybody has been impacted by it. It has changed the way that we're working and interacting, in some ways for good, and in others not so good. But ultimately, we are still, I would say, in the acute phase. And so when we spoke, it was very much like what the impulse reaction from groups like us and others around the world to the fact that we are now entering a crisis, and it is jumped into our backyards, and we are seeing patients get diagnosed left, right, and center. One of the first 10 patients in Canada was actually a very good friend of mine. So it hit me actually very, very quickly. That being said, the first impulse we had when we were last talking was really about protective equipment. So first line of defense, what can we actually do to help protect our healthcare workers? And it was really put a barrier between us and the virus. And so ultimately, myself and the rest of the team at Acorn took all of our protective equipment. We're based inside UHN, and donated it to long-term care facilities and workers in the region that needed it. The second thing we did was offer our laboratory. We run an ISO laboratory, which is the credentials really about the quality of the lab, and we offered that to the Ontario government to use in any testing required. And so those are kind of those impulse things. But I'm going to set the stage a little bit about what Acorn does, what my career has really been focused on, and then how in the long term kind of outlook for COVID, what role it is we really want to be playing once we get past this acute moment. So ultimately, regenerative medicine might be a topic that you're unfamiliar with, but hopefully have heard before. Ultimately, this is our ability to take cells, tissues, and organs and essentially repair their damaged versions inside of us by using replacement parts, so to speak, or tissue from other areas of your body to replace damaged areas inside you. There's been two massive leaps forward that have really opened up the opportunities in this space. And it's two technologies. The first one being the discovery of induced pluripotent stem cells. So that's iPSCs. And what that really means, because that's a long acronym, is the ability to take an adult cell and draw it all the way back into behaving like an embryonic stem cell. That magic moment when sperm meets egg, that cell now has the possibility of becoming any other cell type in the body. And it, as when sperm meets eggs, it develops into that human, and every cell that is going to be needed in that life, we're creating a version of that can be used for all of those purposes. The second amazing breakthrough was Crispr, and this is the ability for us essentially to have cut and paste for the human genome. We've got areas of code that are improperly functioning. We can actually cut that out and put back in the properly functioning code. And so with these two combined technologies, we now theoretically have the tools that are needed to treat and address any disease imaginable. Right? Whether it's traumatic, whether it's long-term chronic disease, whether it's genetic mutations, we have tools to actually address them. We're in the phase of science right now where groups all across the world are taking their own individual expertise and applying these technologies to try to solve a problem, whether it's in the kidney, whether it's in the nervous system, skin, any area, any disease. These therapies somewhere are being used to try to develop a solution for people in the real world. And so ultimately, it is really an explosion of what we see around us in publications of progress forward in developing strategies to combat all of these diseases. And obviously, as we'll get into, COVID-19 is no different. The other side of what I think of a medical era that we're entering into is that around the data that lies inside your own cell. And we call this field omics, and omics is really a catch-all for genomics, epigenomics, proteomics, all of these areas of data that lie within our cells. So we've heard a lot about genetic code and the code that exists there that we are able to look at and identify things that will end up in us in real life. And what we see phenotypically, right? So blue eyes, green eyes, all of those different things. But ultimately, when we think about taking that information And in comparing across different groups, we can actually identify areas of disease and markers that will lead to disease later in life. And it's unbelievably predictive, giving us the ability to actually identify what is going to go wrong far before the first symptom. Now, when you think about it, if you combine these two things, the data and the ability to predict what might develop over time, and then also the tools to treat it, we now have the opportunity to develop tools to eradicate disease and enforce them or use them at a point in time where we actually haven't developed symptoms yet. So these are really setting the stage for doctors, scientists, and physicians around the world to try and eradicate diseases before they show up. Now, unfortunately, sometimes that's impossible because the disease itself is not genetic, is not inherent in either linked to old age or other things. It's actually because of a traumatic incident or an acute infection. But the same principles apply as us being able to use these tools to actually treat those things. And so right now we're in a phase of reaction around COVID where we are trying to mitigate its spread. And so ultimately it is about self-isolation. It's about removing ourselves and the possibility of coming in contact with the virus for as long as possible, really in an effort to try to minimize the burden on our healthcare system. We know some numbers that are out there as far as the number of people that actually need really acute medical care, right? So need to be hospitalized. And the reality is, if those numbers, if everybody across Canada were actually infected, unfortunately, our healthcare system would be overwhelmed. And so right now, that's the focus. But for us moving forward, after we get through this phase of trying to minimize the burden on our healthcare system to treat those that get exposed to the virus, our role is really focused on what the long-term implications for those that have recovered and have had severe symptoms will be. And all of those technologies that I just talked about before, what they will really have as a role to play in the mitigation of the development of these second order implications of having COVID-19. And so we've seen across the globe many reports of different conditions. One of the most recent that was actually a little bit scary to me because it really exemplifies the severity of this was a group in New York, a hospital network system that had over 5,000 cases of COVID that checked into a hospital. So these are patients that had severe enough symptoms that they needed to go in and seek medical attention. So over 5,000 went in, and after they recovered, 1/3 of them experienced kidney failure. And it's only been about 3 months since the first wave of patients came in. So what we're really seeing here is for the group of patients that do experience those severe symptoms, there are going to be long-term implications outside of just what we have been describing as the symptoms of COVID-19. We're going to see actual organ failure. We're going to see long-term chronic disease that exists in different areas. And we've already identified that can persist in the lungs, which is really that primary source of infection. Most of the patients that get hospitalized are actually treated for ARDS, which is acute respiratory distress syndrome, and then kidney disease, as this latest study just really showed. On top of that, we've seen heart conditions, so stroke in patients that have recovered from COVID, and then also even circulatory disease. It's actually a very rare disease, an autoimmune disease that mostly shows up in children, but we've seen a huge surge in cases amongst the population that have recovered from COVID. So, it is unfortunately one of those diseases that I don't think is going to be passing us by, right? I think that this is something where we're going to see our immediate response right now to help try to prevent acute deaths from infection. But we need to have people that are focused on the actual long-term implications moving forward and some of the organ damage. And that is where I feel like tissue engineering has an opportunity to help fight COVID-19. There are a multitude of areas that the groups in tissue engineering and in this space have gotten involved in the response to COVID-19. Everything from in vitro testing towards development of drugs and vaccines on tissues that have been removed from the body to study their effects without having a live human subject, just the cells themselves and their response, all the way through to thinking about how we can actually take our own cells, modify them, preserving the health and functionality of those cells to actually use as a therapeutic, a cell-based therapeutic that can combat the long-term chronic disease that may be left in some patients after they've recovered, including in the lung, kidney, heart, and circulatory system. And so that's been an immense amount of our focus moving forward, as being a group that is very much focused on preparing people to have their best cellular material, to be able to have their best chance of giving themselves long-term health as we age. So I think that one of the major things that we really need to be thinking about here is collaboration. And I've been, if there is a silver lining in this situation, what I've really seen is that there is an extreme willingness of scientists and groups and academic centers, and even in the private sector across the globe, willing to work together and come together to develop these solutions. And I think that we've seen a multitude of things fast forward in progress. The first is an example of what we're doing right now, speaking online on this webinar. I mean, obviously there were webinars before this. I can't say that I was nearly part of as many webinars as I was pre-COVID as I have been post-COVID, but we are all getting very used to working remotely and being able to be productive no matter our surroundings, and not necessarily have to be in an office chained to a desk to be productive. And so that movement of being able to work remotely has been fast forwarded. I think collaboration scientifically has also been fast forwarded. The response from groups, private and academic, in our space and coming together to address these solutions has been extremely profound. I'm very excited to say, even over the last 2 days, we've been speaking with one of the groups that we were working in before COVID broke at Mount Sinai Hospital here in Toronto, about getting back our project running again and opening back up the laboratory, the research side of the laboratory, which has been shut down. So those are some of the things that we're seeing actually start to come back to productivity since that acute phase of everybody scatter and duck and hide and try not to come in contact with each other to stop that spread. So that is a bit of a summary of what has gone on since our last conversation, Andrea, but I'm excited to continue the conversation.
So you haven't been busy, I can tell.
We've been extremely busy. There's more, but I'm sure we'll get into it.
Yeah. So, as I listen to you, one of the things that jumped out is, that these implications are due to sort of the body's immune system starting to fight itself. So help me to understand this better. Is this sort of like, an autoimmune disorder where we see the immune system attacking the body, similar to like lupus, or maybe one of those other types of autoimmune that we've heard of and maybe don't really understand?
Yeah, so there are absolutely autoimmune diseases that would have the same kind of effects as far as having damage. And ultimately what is happening is you have this surge and this increase that goes beyond what is actually needed to combat a disease in your body. So in this case, a little bit different than some of the genetically linked autoimmune diseases, where we just have this overexpression of our immune system in certain areas. But there is actually an infection that we are fighting off, except unfortunately we don't clear it that quickly. Our immune system continues to build up a defense against it, and actually is overcompensating and over inducing this effect to the point where all of those attributes end up doing damage to our own systems. And in COVID-19, we actually see that primarily in the lungs, and that's where you've probably heard that there is a need for ventilators, and we're trying to accumulate as many ventilators as possible to help mitigate patients that need care in having access to them. And that was one of the major limitations in what we felt was our capacity to actually be prepared for treating patients. And so for us, the lungs was really the first marker of where this long-term damage could potentially reside, but also that most immediate acute potential for death, right? So we have to, obviously the ventilators were very important to try to recover from that surgence of the immune system. But unfortunately, what we're now seeing is there are long-term damage that exists. And so it is not totally unsimilar to other things that have happened, where you have this moment where there's a large loss of life, or there's a large threat of loss of life. And even something that was not a virus, but to still have had impact on the lungs was actually the attacks on the World Trade Center. So, we can compare it to other autoimmune diseases. We can also compare it to other incidences in history that hopefully we can learn from. But in that instance, almost 3,000 people died very, very quickly in that day when those towers ended up collapsing. And but ultimately, there's about 90,000 people that were exposed to the smoke and the dust and the carbon nanotubes that were rendered into an aerosol into the air. And so ultimately, we ended up seeing over the course of years, more and more patients emerging that were either first responders or on the street and did escape with their lives, developed very severe lung infections, swelling, fluid in their lungs, and even for some, cancers developed. And so these implications showed up years after that initial onslaught onto their lungs. And so although that was a non-viral, but still obviously detrimental to their lungs, now we have a virus that is inciting this massive autoimmune response where we're actually damaging our lungs. What are going to be the long-term implications of the group, especially those that have very severe symptoms? They, a lot of people are recovering. They're definitely, deaths, but there are a lot of people with very severe symptoms that do come back. And what is their lives going to look like moving forward? And what things are we going to see start to emerge? As that study showed, 1/3 of the patients that had severe symptoms and required hospitalization developed kidney failure this quickly afterwards. Is that number going to increase over time? And so we need to be thinking about what the long-term impacts of COVID-19 are on those that have recovered, because ultimately, we need to be as prepared as possible that COVID-19, unfortunately, is not over for some of these patients. And there are going to be some long-term health implications that they're going to need attention for the rest of their lives, potentially. Even ones that maybe don't show up for years, but as they age and as maybe the lung capacity diminishes over time, normally due to age, we'll start to see them emerge, and they'll need attention then.
Wow, Drew, you're painting
I'm not trying to.
Well, I think it's important though, and the long-term implications are really important. And I know that at Acorn, you guys do stem cell banking, right? And I think most of our listeners probably aren't even aware of this thing called stem cell banking. And what I know of it is that it's a way of taking my cells today and banking them for when I need them later. And so as I'm listening to you, and I also think about, in my own life, I recently watched my own sister go through a stem cell transplant, and she got a stem cell transplant from my brother, who was a donor. And I wonder, as I look at the work that you're doing, some of the research that's happened already in the past on stem cells, and some of the work that's happening in the future, as a healthy person today, should I be banking my stem cells so that, I don't have these long-term implications? I mean, it just seems like a natural question of like, because what can I do? And if I were to bank my stem cells, would I in fact have a better chance on a better outcome?
Amazing questions. Stem cells has been a hot topic for a long time. And I can, remember the first kind of moments of stem cells actually percolating and reaching some of the mainstream media areas. People just in the general population were like, amazing, stem cells are here. When can I get mine and we'll be able to cure anything? Like, as the possibilities emerged, unfortunately, the patience was not as high as the enthusiasm. So ultimately, stem cells is something that is a tool that we are going to develop over years to combat different things. And ultimately, our role in this is trying to prepare you to make sure that you have the best chance at capitalizing on every one of these discoveries and utilities of stem cells. And so ultimately, I think that we do need to have a little bit of patience. And I kind of like to compare it to the Wright brothers. You know, if you went over to the Wright brothers the day after they invented flight and said, okay, amazing, take me to London, England, you would have gotten wet. Their first flight was, 100 feet, right? It was not going to be anything that was going to necessarily take you very far. And so stem cells is really the same thing. But what we have seen in my career, in my short career, really, in the span of things, is amazing leap forwards in technology that have continued to just have this exponential effect on the possibilities of what these cells can do. And we are now at this kind of moment, this watershed moment, where there are now 60,000 patients registered in clinical trials for stem cell therapies across the world. We have groups in Israel that are 3D printing miniature human hearts and implanting them, right, in animal models for testing.
Incredible.
But you can see very quickly, we are now making the necessary steps to see these things actually start to help human beings from bench to bedside. But that does take time. But it is coming extremely quickly. There is no doubt in my mind that in our lifetimes, we are going to be seeing organs made on demand and implanted. Really, the question is just when in our lifetimes is it going to happen? Is it going to happen in 5 years, 10 or 20, right? And so for those kind of things, preparation is really what we can do to make sure that we're in our best situation. The facts that we know are as we age, unfortunately, a lot of damage accumulates. We end up getting sick. And precisely at the moment when we're at our worst, usually later in life, and disease hits us hardest, our resources, our internal resources that we have are at their absolute worst. And we need them to be at their best. And so by actually preserving yourself with as much distance from the point in time that you're going to need them, as much time as you can where damage doesn't accumulate and you haven't experienced disease, and those cells are a stronger resource for you, if you can harness that power at that point in time, which honestly is right now today, then you're going to be that much more better prepared to have a better starting material for these therapies in the future. And there are examples historically of groups making the decision to prepare, and unfortunately groups that haven't. And a great one as far as like a medical technology that evolved was actually around DNA. And so police forensic units in the 70s and into the early 80s really could do very minimal work around determining what was present in biological samples that were left at crime scenes. So you could take a spot of blood and you could say whether it's A, B, O, and you could narrow out suspects or narrow down suspects, but you couldn't ID a suspect like we can today genetically. That really didn't evolve until the early 80s, where in the first case, I believe it was 1984, in London, the DNA was used in a very new technology that had just emerged that year to actually identify with 99% certainty that this biological sample came from a very specific individual. Now, that level of analysis, some groups said, you know what, it's coming. We can only do blood typing today, but we're going to be able to do so much more in the future. We know what DNA is. It has been identified. We know the potential power of it. Just like today, we know the potential power of stem cells. And so there were forensics units that actually said, let's bank these samples. Let's preserve the biological samples. Let's do the testing we can on today, and let's save the rest. And they invested in the infrastructure and the cold storage and things to actually save those samples. And for the groups that did that, hundreds of cold cases were brought back to life, and unfortunately, justice was fortunately justice was served, and some of the crimes were horrific, and obviously it's not enough. But ultimately, we were able to go back and actually identify murderers and assaulters and put them behind bars, only because certain groups had the foresight to say technology is advancing and we want to be prepared for it.
That's amazing. And, as I listen to you, so this idea of banking my stem cells is important. But, as I look at my, again, I go back to my own personal situation, my brother and my sister, and I watched my sister recover from this transplant, and it was incredibly difficult. And thank God to both my brother and my sister, and to, the powers that be, she's recovered and she's doing fantastic. but she, it was tough. And, like, what's the difference between taking somebody else's stem cells, as I saw there, and
Mhm.
taking my own? Is there a difference?
There's an absolute difference. And look at, we work within the best tools that we have that are available to us today. And so unfortunately right now, sometimes we need to try to find a donor. We need to try to find a match. That's not ideal for a number of different reasons, but it still is an immense gift that we have the ability to at least give a chance by finding a donor to that individual to recover. But the unfortunate side is you have to find a very exact match. And sometimes you're never going to get a perfect match. That's impossible unless you're taking it from yourself, right? And so you're taking it from a donor. You get as much of a match as you possibly can, but you still, no matter what, have to put that individual on immunosuppressants. So we actually lower their immune system, and unfortunately their ability to fight off anything else that they might come in contact with, all in the effort to have them not reject that donor's cells. And so we have to remove that immune response from that patient so that they will accept the cells from that other individual, but it leaves them very susceptible to a host of other things. And I've absolutely in my career known people that have actually gotten pneumonia and not been able to fight it off. And that can actually, unfortunately, kill you, right? Because you don't have an immune system to combat it because we've suppressed it. So lots of risks that we're undertaking. Ultimately, the best possible scenario is to have your own cellular material. It is yours, your unique genetic code that will not be rejected by your own immune system. And so that is why this is very much a personal effort that you are making to prepare by taking your own cells and making sure that you've got the best version of yourself frozen down and preserved.
And I just noticed, so we're streaming today live to Facebook, and my sister is actually watching us. So just a shout out to Lavon. And she
Yes.
had a question on Facebook. She was wondering of the use of CRISPR in editing cells, and sort of looking at the future of what could that look like.
Yeah, so CRISPR is extremely exciting. If you think about the possibilities of being able to actually edit genetic code, a lot of the diseases, we already have, I believe it's over 1,200 different diseases right now that we have identified the code that is responsible for inciting that disease. And there's a whole host of other diseases that we know that certain segments of code have an influence on developing that disease. There's a huge discovery here at Sick Kids Hospital where there is an actual gene that was identified that if it was present in a certain form, it led to 100% of patients that had this code were autistic, right? The biggest link in autism genetically that we've ever experienced happened right here at Sick Kids, Dr. Stephen Scher. So these kind of tools are constantly emerging and being discovered. And ultimately, if the more knowledge we have on what that code is, it incites disease, and what it should be that will code for proper function, we would be able to actually take a population of cells. For instance, at Acorn, what we do is we take your population of cells and we'd edit out that code that is improperly functioning and leading to disease, put in the properly functioning code, and in the future then they take those cells and implant them into you to repopulate with the properly functioning code in your system. So that is like what we see in the future as one of and that's why CRISPR is such a powerful tool at treating disease.
That's incredible. I mean, so just to put that in a real sense, looking at this example that I've been using of my sister, she could have had that, take her genetic code, if the cancer was genetic, take it out of the code, put it back in, cancer is gone. It resets the entire body.
Absolutely. And so, not knowing the details, but ultimately there are many links to susceptibilities for cancers genetically. And ultimately, as we start to get more and more information and absolute clarity with specific examples of what it will lead to, the power is to go in and eliminate those things. And the better we get at it and the better prepared we are for it, ultimately we'll be getting it earlier in time points in our lives, hopefully after mild, if not even before any symptoms.
I'll bring it back to COVID and looking at some of the things that are happening out there and some of the reports that are becoming circulated. So, there are lots of of discussions around the COVID-19 virus and what causes it or what makes you more susceptible. I've seen everything from your blood type to the fact that, or the assertion that the non symptomatic carriers are less than. So there's lots of information out there around the COVID-19 virus and what we can do. Tell me about what we do know in terms of how it presents and how we can better know if we're susceptible to it.
Absolutely. So those are great questions. So the first thing that I will say is ultimately there are some non-genetic, some very obvious factors that greatly influence our susceptibility to COVID. And so, and they really are surrounding our general health, our age. You know, we've all seen reports on the terrible results of cases that actually led to outbreaks in long-term care facilities. And so age is a huge factor. The elderly definitely do not have the same ability to fight off this virus. That being said, there are also cases of people that are on immunosuppressants, cases where people have had, even if it's due to traumatic injury, the need to have a kidney or a lung removed. So their capacity to one filter or their capacity, their VO2 max, all of those things being diminished leads you to being more susceptible to very severe infections and symptoms from the virus. But there are also genetic things as well. We know the actual way the cell enters our cells. It binds onto a very specific receptor. There are mutations in that receptor. And one of the things that we're working on is looking at different ways and different variations genetically of that receptor that could lead to levels of immunity that will be higher in individuals that have certain versions of that receptor that is targeted by SARS-CoV-2. And so that is a huge area of discovery right now that we are embarking on to try to identify some of the molecular things that we can use as diagnostics, predictive diagnostics, to allow us to understand better whether we have susceptibilities to developing severe symptoms from an infection. There are also other elements. So there are a number of studies that have happened before, during times of SARS and other coronaviruses that have had much smaller impacts, but still had outbreaks. And there are a number of markers in individuals, most of them that actually are very specific to lung function, capacity. A lot of these different markers will actually lead us to being more susceptible to respiratory viral infections as a classification of a number of different viruses, SARS-CoV-2 or COVID-19 included. Right, so there's some general ones and some very specific ones based on the molecular mechanism that this virus enters our cell. And that is something that me and my team are working on very closely in trying to play a role in developing a play sheet, a game sheet that allows us to determine the susceptibility of an individual if they do come in contact. I think that for the most part, we should really commend ourselves. We have very much bought into, for the most part, the self-isolation measures. And I'm really grateful for all of the people that took it as seriously as they did, because I think it saved a tremendous amount of lives. Now, there are absolutely, we have to get back into an economic standing. I mean, death by COVID or death by economy will soon be a question. But we are getting back to work, and we have minimized that initial surge that could have overwhelmed our healthcare system. But now, as we move forward, we need to be developing tools to allow us to predict those members of our population, both because of their patient history, right? So their data on file, including their age, their other compounding factors, and things like our hypertension, diabetes, all of these things have links to make us more susceptible, as well as our genetics. And if we can actually predict and identify the people that will have a very severe reaction, we can do better to protect them, and we can move faster to treat them if they do get exposed. And I think that'll give us a huge advantage in trying to mitigate the slowing down of the economy and our back to work progress, but also make sure that we're paying very specific attention to those that might actually have a very severe reaction.
Drew, you've given us a lot to think about today. There is
Yeah.
absolutely an incredible amount of work that sounds like it's going on. You talked about collaboration. You've talked about, the role that stem cells could play in the future. You've given us a view of what those long-term implications could be. And I think, for many of us, we're sort of in this place of, finally some of the lockdown controls are easing, and we're thinking about going out. But I think, the reality is we have to think beyond what's happening in the world or in our world today, because those long-term implications can be as dire or as serious as the virus itself. So understanding how to take care of ourselves now, how to identify what those could be in the future, and what are the things that we need to know about to make sure that we could in fact have a better outcome should we have some of these outcomes. So looking at stem cell banking, I'm a big advocate of it. When I first met Drew, it was one of the first things that once I understood it, I was like, okay, so how do I give my stem cells? And so I actually, because I do truly believe that we should all be banking our stem cells today. Drew, can you tell us just a little bit about what that looks like?
Sure. Yeah, so we spent a great deal of time investigating ways that we could extract a premium source of cells from you for use in the future non-invasively. And so ultimately, we can do it as simply as through the hair follicles on your head. This micro little mini organelle is an amazing cluster of cells. And so through the plucking of those hair follicles, that cluster of cells can be used and leveraged to create other types of cells in your body in the future. There's been some amazing work that's shown the utility of the hair follicle and the multitude of different cell types naturally that are contained within this mini organelle. But it also has been shown to be an amazing source of cells for use in creation of iPSCs. And so then you open up the window to say the cell is now possible of becoming any different cell type in your body. It's accessible, it's cheap, right? Like ultimately, when you think of stem cell therapies, you think of I don't know, but I think of some science fiction movie where there's some fancy machine extracting all of these things. The reality is a source of your own cells that are robust and able to become these iPSCs, able to CRISPR to be used on them. That is what we need. And so we can do that from as simple as hair follicles. And so, I kind of like to joke around that if you can afford Stranger Things, then you should get your stem cells banked because for the price of Netflix, you can actually preserve your cellular material to leverage in the future for all of these amazing breakthroughs and technologies.
That's incredible. I mean, first of all, thank you for the work that you do as a scientist and as a researcher. It's incredible to see what's happening. And regenerative medicine is an area that, we have the privilege of working with a number of regenerative medicine scientists at Talk Boutique, and we've had the privilege of working with you. And so I am incredibly grateful for the work that you do and for choosing science over baseball, as hard as I'm sure that was. Where I'm going to end today because we're almost at time. So thank you again for your time. Thank you to everybody who stayed with us. We've had an absolutely fantastic conversation. Please make sure to come back and join us next week. We are starting our Courageous Conversations. In fact, tomorrow is our first Courageous Conversation, and with John Robinson Jr., who many of you met last week. John will be speaking with Oziona Iguanawanu, who will be talking about the exponential possibilities of ending racism. And so that's going to be an incredible conversation. Join us on Friday of this week for another sense-making conversation with Sandra Elia, who will talk about how our eating habits can change the way in which we impact our lives and our risk factors and things like COVID-19. So come back, join us. Thank you again, Drew, and thank you to all of you. It's
Oh,
been my
thank you.
absolute pleasure, and stay healthy, stay safe, stay connected. Take care.